Hello and welcome to Cloud Champ. This is the first video in the playlist AWS Real Exam Questions for Solutions Architect Associate. In this playlist, we will cover questions to practice for the Solutions Architect exam, and most of these questions will be there in your exam or similar questions like this. So if you practice these questions, I will give you 100% guarantee that you will pass your exam with a good score. Follow a pattern where I will show you question along with the answers. You can pause the video, try to guess the answer. Alright, so you will see a screen like this and I will read out the question for you. You can pause the video and try to guess the correct option among this. Then we will go through each of the option and find the correct one. I'll explain you why it is the correct option and why others are wrong. So even if you have not learned the topic, you can learn the topic as well as you can get the questions. So it's a win-win situation. So please subscribe and let's get started. This is the part 1 for the AWS Solutions Architect real exam questions. I'll be uploading videos like this, and if you like the videos, please subscribe to the channel. So let's get started. The first question is, an application saves the logs to an S3 bucket. A user wants to keep the logs for 1 month for troubleshooting purposes and then purge the logs. What feature will enable this? So the question is asking that the user wants to keep the log for 1 month, and after that he wants to delete the log after 1 month. So you can pause the video and try to figure out the right answer. Okay, so according to the question, this is a feature of S3 that is called as lifecycle management. So let's look at the options one by one. The first option is adding a bucket policy on S3 bucket. A bucket policy is permission granted to the bucket in S3. So the question is not asking for any permissions. So this is not a valid answer. The second is configuring lifecycle configuration rules on the S3 bucket. So lifecycle configuration is what the question is asking for. But let's look at the other options as well. Creating an IAM policy for the S3 bucket. This does not apply for this question. We are not asking for any policy or permissions, so IAM policy is not asked here. The last is enabling CORS or cross origin resource sharing on the S3 bucket. Cross origin resource sharing is enabled when you want to access your S3 bucket from another account or another region. So this is not what the question is asking. So the correct answer is the second answer, that is configuring lifecycle configuration rules on the S3 bucket. You can read this explanation here. Now let's switch to the second question. So a company is storing an access key and secret access key in text file on the custom AMI. The company uses access key to access DynamoDB tables from instances created from the AMI. The security team has mandated a more secure solution. Which solution will meet the security team's mandate? So according to the question, the user is using access key ID and secret access key on the custom AMI, which is not best practice according to AWS. Pause the video and read the question carefully and try to guess the correct answer. So the first option is put the access key in an S3 bucket and retrieve the access key on boot from the instance. So this is not a valid answer. You should never put or expose your access or secret access key. The second is pass the access key to the instance through instance user data. Not good practice, not best practice. When you want to provide a role to any service, in this case we want the AMI to access DynamoDB table, so we can give the AMI a role, IAM role. We should never expose access key. The third option is obtain the access key from a key server launched in a private subnet. No, we should never do that. The fourth is create an IAM role with permissions to access the table and launch all instances with the new role. This is the correct answer. AWS suggests you to use roles whenever you want to give permissions to access other services. So the correct answer is create an IAM role with permissions to access the table. Here is the explanation. Let's move to the next question. A company has deployed Amazon Redshift for performing analytics on user data. When using Amazon Redshift, which of the following statements are correct in relation to availability and durability? So these are the options given. We have to check which are the correct features about Amazon Redshift. So you can pause the video and read the question carefully now. So the options we have here is the first is Redshift always keeps 3 copies of your data. The second is single node clusters support data replication. The third is Redshift provide continuous or incremental backups. Manual backups are automatically deleted when you delete a cluster. Redshift always keeps 5 copies of your data. So Redshift always keeps 3 copies of your data. The single node clusters do not support data replication. Redshift provides continuous or incremental backup. Incremental means if you have already created a backup, the changes that you have made after creating the backup will only add. So it is incremental. This fourth is manual backups are automatically deleted when you delete a cluster. The manual backups do not get deleted automatically. You have to delete it from console or from CLI. And the fifth is Redshift always keeps 5 copies of your data is wrong because Redshift always keeps 3 copies of your data. So the right answer is the first and the third option. Next question is a company is developing a highly available web application using stateless web servers. Which services are suitable for storing session state data? So we need a database which is suitable for storing user session data. So please pause the video and try to guess the right answer. The options we have here is CloudWatch. CloudWatch is a monitoring system by AWS and it is not a database or a storage system. So this is not the right answer. DynamoDB is a NoSQL database in AWS. So this can be an option, but let's check the other option as well. Elastic load balancing. Elastic load balancing is used to manage the load between instances. It is not a storage or database service. So this is not the right answer. Elastic cache is a in-memory database service which has Redis or memcached. This can be an answer, but let's check the last one as well. Storage gateway. Storage gateway is used to integrate between the AWS and the on-premise storage, and it is not suitable for storing session data. So the correct answer is DynamoDB and Elastic Cache. You can read out the explanation here. Let's move on to the next question. A client from a large multinational corporation is working on a deployment of significant amount of resources into AWS. The client would like to be able to deploy resources across multiple AWS accounts and regions using a single toolset and template. You have been asked to suggest a toolset that you can provide this functionality. So client is working on different regions and different accounts. He wants to have a single toolset that he can use in all the accounts. He don't want to repeat the task again and again. So this can be done using a service called as Cloud Formation, which lets you create templates or stacks so that you can use the same stack everywhere. You can pause the video now and try to figure out the right answer. The first option we have is use a CloudFront formation template that creates a stack and specify the logical IDs of each account and region. According to AWS, a regular CloudFormation template cannot be used across regions and account. You would need to create copies of template and then manage the updates. So this is not the suitable option. The second is use a CloudFormation stack set and specify the target accounts and regions in which the stacks will be created. So the AWS CloudFormation stack sets extend the functionality of stacks by enabling you to create, update, or delete stacks across multiple accounts and regions with a single operation. So you can create the same resources using stack set. You just need to specify the target account and the region in which you want to create it. This seems to be a correct answer, but let's just check the other answers as well. You can use a third party product such as Terraform that has support for multiple AWS accounts and region. You don't need to use Terraform even though AWS has its own service Cloud Formation, so you don't need to do this. So this is the wrong answer as well. So last is this cannot be done. Use separate Cloud Formation templates. This can absolutely be done, and so the right answer according to the question is the second one, that is use Cloud Formation stack sets and specify the targets and region in which the stacks will be created. Next question is, a new big data application you are developing will use hundreds of EC2 instances to write data to a shared file system. The file system must be stored redundantly across multiple AZs within a region and allow the EC2 instance to concurrently access the file system. The required throughput is multiple GB per second. From the options presented, which storage solution can deliver this requirement? So the question is asking for a shared file system that should be available across multiple AZs. So you can pause the video and try to figure out the right answer. So the first option we have here is Amazon EBS using multiple volumes in a RAID 0 configuration. Amazon EBS volumes cannot be accessed by concurrently many or multiple instances, so it can be accessed only by a single instance. Amazon EBS is a block store which can be accessed by only a single instance. Question is asking for a file system which is going to be attached to multiple EC2 instances. So this is not the correct answer. The second is Amazon EFS. Amazon EFS is the best solution as it is file level storage and stores data redundantly across multiple AZs within a region, and you can concurrently connect up to thousands of instances to a single file system. So this seems to be a correct answer, but let's just check out the other answers as well. Amazon S3. S3 is object store and not a file gateway, so this is not the right answer. The fourth is Amazon Storage Gateway. A storage gateway is a range of products used for on-premise data storage management and can be configured to cache data locally, backup data to the cloud, and also provide a virtual tape backup solution. So this is not the right answer as well. The correct answer is Amazon EFS, which is a file system and can be attached to multiple EC2s. The next question is, you need to configure an application to retain information about user session and have decided to implement a layer within the application architecture to store this information. Which of the option below could be used? So you want to store user session and you need to implement a layer within the application architecture. So you can pause the video and try to figure out the right answer for this. The first option we have is a workflow service such as Amazon Simple Workflow Service are used for carrying out series of tasks in coordinated task flow. They are not suitable for storing session data, so this is not the correct answer. The second is sticky session on Elastic Load Balancer. So sticky session, also known as session affinity, allows you to route a site user to a particular web server that is managing that individual user's session. The session's validity can be determined by a number of methods, including the client-side cookie or via configurable duration parameter. So when you enable sticky session in Elastic Load Balancer, your user will be directed only to a particular instance, and this can be used to store the session, to get the session data as well. So this seems to be a right answer. Let's move on to the next option. A relational data store such as Amazon RDS. Relational databases are not typically used for storing session data due to the rigid schema that tightly control the format in which the data can be stored. So this does not seem to be the perfect answer, And the last option we have is key value store such as Elastic Cache Redis. And Elastic Cache Redis is a key value store which is perfect for storing session data. So the two options which are correct is the second and the fourth option, that is sticky session on Elastic Load Balancer and key value store such as Elastic Cache for implementing a cache layer. The next question is a data scientist in your company looking for a service that can process and analyze real time streaming data. So the question is asking to analyze real time streaming data. And whenever you see real time streaming data or anything real time in the question, you should always choose Kinesis. To store real time data, we use Kinesis data stream, and to analyze or to do analytics on real time data, we use Kinesis data analytics. So the first option seems to be correct, but let's check the other option as well. The Kinesis data streams and Kinesis Firehose. The data stream is used to store the custom app to store or analyze streaming data for specialized need, and Firehose on the other hand, Firehose cannot be used for running SQL service. So this combination is not the right one. Elastic Cache and EMR. Elastic Cache is an in-memory database, so it is not used for real-time streaming. And EMR is a Hadoop framework for big data, which cannot do analytics as well. So this is not the right answer. The last option is DynamoDB and EMR. So DynamoDB is a NoSQL database that can be used for storing data from a stream but cannot be used to process or analyze the data or to query it with SQL service. Whereas EMR is a hosted Hadoop framework and not suitable for analytics as well. So the right answer is the first option, Kinesis data stream and Kinesis data analytics. The next question is, which of the following approaches provides the lowest cost for Amazon Elastic Block Store snapshots while giving you the ability to fully restore data? So the question wants you to find out the lowest cost for Amazon EBS snapshots. So pause the video and try to figure out the right answer. The first option is maintain a single snapshot. The latest snapshot is both incremental and complete. So in EBS, you can take snapshot periodically. The scenario is that you need to reduce storage cost by maintaining a few EBS snapshot. So you can also maintain a single snapshot, and it is always the latest snapshot is both incremental and complete. Incremental in the sense means you took a snapshot, and if you made changes, only the changes is going to be saved, not the whole again. So this is the first option seems to be correct. The second is maintain the most current snapshot and archive the original to Amazon Glacier. There is no need to archive the original snapshot to Amazon Glacier. EBS copies your data across multiple servers in different availability zones for durability. So this is not the right answer, and this is not a cost effective as well. The third is maintain two snapshots, the original snapshot and latest incremental snapshot. This is also not the right answer because a single snapshot is both incremental and complete. So this is not the correct answer. The last option is maintain the original snapshot. Subsequent snapshot will overwrite one another. This is not the correct answer as well. The correct answer is maintain a single snapshot and the latest snapshot with both incremental and complete. The next question is, you are looking for a cost effective way to convert the files from their current format into format that are compatible with smartphone and tablets. The files are currently stored in an S3 bucket. What AWS service can help with converting the files? So the question is asking for a service that can convert file from one format to another. So you can pause the video now and try to figure out the correct answer. The first option we have is recognition. So recognition is a deep learning based visual analysis service. It is not used for converting files from one format to another. The second is Amazon Elastic Transcoder, which is highly scalable, easy to use and cost effective way for developers to convert videos and audio files from their source format to other formats. So this seems to be a right answer. The next option is data pipeline. Data pipeline helps you to move, integrate, and process data across AWS compute and storage resources. So, this is not something that you can use for converting files. The last is the Amazon Personalize, which is a machine learning service that makes easy for developers to create individualized recommendation for customers within the application. So, the second option, that is Elastic Transcoder, is the correct option. The next question is, a large multinational client has requested a design for multi-region, multi-master database. The client has requested that the database be designed for a fast, massively scaled application for a global user base. The database should be fully managed service including the replication. So the question asks for multi-region and multi-master database, and it should be global user base. So you can pause the video now and try to figure out the right answer. The first option we have is S3 with cross-region replication. S3 is an object store and it is not a database. So this is not the right answer. RDS with multi-AZ. RDS database is not a multi-master database, which the question is asking for. So this is not the correct answer either. The third option is DynamoDB with global tables and cross-region replication. DynamoDB has a feature of multi-master and is very fast, massively scaled application database. This seems to be a right answer, but let's check the fourth option as well. That is EC2 instances with EBS replication. So EBS replication is not a thing in AWS. So this is not a correct answer either. The correct answer is DynamoDB table with global tables and cross-region replication. Next question is, customer has asked you best solution for highly available database. The database is a relational OLTP type of database and the customer does not want to manage the operating system the database runs on. Failover between AZs must be automatic. Which of the below options would you suggest to the customer? So the question is asking for OLTP relational database and the customer does not want to manage the operating system. So he wants a managed database and the failover between the availability zones must be automatic. So it should be multi-AZ database. So you can pause the video now and try to guess the right answer. So the first option we have is RDS in multi-AZ configuration. So RDS is managed OLTP relational database, and we also have multi-AZ configuration here which can fail over between AZs automatically. So this seems to be a right answer, but let's check the other options as well. Use DynamoDB. DynamoDB is OLTP, but it is not a relational database. So this is not the correct answer. The third is use Redshift in multi-AZ configuration. Redshift is not an OLTP database, it is OLAP database. So this is not the correct answer either. The last option is install a relational database on EC2 instance in multiple AZs and create a cluster. So the question is asking for managed database. The customer does not want to manage the operating system, and here we have to manage the EC2 instance on which we will install the database. So this is not the correct answer. The correct answer is the first option, that is RDS in multi-AZ configuration. The next question is, an application uses auto scaling and fleet of EC2 instances. You recently noticed that the auto scaling is scaling the number of instances up and down multiple times in the same hour. You need to implement a solution to reduce the amount of scaling events. The solution must be cost effective and preserve elasticity. What changes would you implement? So the question is asking that the auto scaling is launching and terminating instances very quickly in 1 hour. So you want to change the settings, and it should be cost effective, preserve elasticity. That means the auto scaling should work as well. So you can pause the video and try to guess the right answer. The first option is modify the auto scaling group termination policy to terminate the newest instance first. The order in which autoscaling terminates instances is not the issue here. The problem is that the workload is dynamic and autoscaling is constantly terminating and launching the instance. So even if it terminates the newest instance, this is not going to solve the problem. So this is not the correct option. The second is modify the autoscaling group cooldown timers. The cooldown period is a configurable setting for an autoscaling group that helps to ensure that it doesn't launch or terminate additional instance before the previous instance has been terminated. This seems to be a right answer. The third option is modify the CloudWatch alarm period that triggers your autoscaling scale down policy. So the CloudWatch alarm is responsible for the scaling events or the scaling because autoscaling is based on the CloudWatch alarms. This would help as you can increase the number of data points required to trigger an alarm. The fourth is modify autoscaling to use scheduled scaling actions. There is no problem in the scaling policy, so we don't need to change it to schedule scaling actions. The last is modify the autoscaling to terminate the oldest instance first. The order of termination is not an issue here, so that's not the right answer as well. The correct answer seems to be second and the third, that is modify auto scaling cooldown timers and CloudWatch alarm period that triggers your auto scaling scale down policy. This is the end of the part 1. I hope you liked the video and learned something. Please subscribe to the channel, and if you have any doubts or anything you want to say, please comment down. Also check out the part 2 of the AWS practice questions, where we will learn all the real exam question, and this will help you for your AWS certification. Have a good day.